So what I want to do here is to provide a little demonstration to show the energy stored in a coil in the form of magnetic field. And this also demonstrates the property of inductance, that a changing current in an inductor or a coil induces a voltage that opposes that change in current. So what I have connected here is a neon lamp. Now the neon lamp is simply a bulb that's filled with neon gas, and neon gas being one of the inert elements or one of the noble gases, it takes a lot of energy to cause conduction through the neon gas inside the bulb. And for this particular neon lamp, it requires about 75 volts for conduction and illumination of the lamp. Now, connected across the neon lamp is a digital multimeter, so we can monitor the voltage across the lamp. And then connected to the lamp is the output of a dual DC power supply. Now, this power supply, again, has two power supplies in one piece of equipment. There's a power supply here, positive to negative, another power supply here, positive to negative. Each power supply has an independent control. Now, each of the two power supplies can output 40 volts. So what I'm going to do is I'm going to turn on the power supply, and I'm going to increase the voltage from the left side. And of course, we're monitoring the voltage output of the power supply with the DMM. And I'll turn this up until it reaches its limit of 40 volts. You can see this displayed on the digital multimeter. Now, as you see, this 40 volts is not enough to illuminate the neon lamp. So I'm going to turn up the other side of the power supply. And of course, you can see the output voltage across the lamp is increasing. And when we reach about 75 volts, the neon lamp will light. So there we are at 76.4 volts required to illuminate the neon lamp. So I've built another circuit here. And this circuit consists of a 9-volt battery, and connected in series with the 9-volt battery is a single pole, single throw switch. And that connects to an inductor, a 100 millihenry inductor, connected in parallel with a neon lamp. Now, when I close the switch, current will flow through the inductor, and that current will create a magnetic field in the inductor. And when I open the switch, there will be a voltage induced, which will oppose that change in current through the inductor. And this induced voltage will hopefully be large enough to illuminate the neon lamp. So let me zoom in here just a little bit so we can see more better. There we go. Now, I'm going to close the switch. So now current is flowing through the inductor. Again, a magnetic field is generated in that inductor. And when I open the switch, again, the magnetic field collapses, which will induce a voltage that attempts to keep current flowing through the inductor. And let's see if it'll light the lamp. There we go. Hopefully you saw that. Let's do it again. So the switch is on, current flows through the inductor. The switch is off, collapsing magnetic field. The switch is on, current flow through the inductor. Switch is off, collapsing magnetic field induces a voltage. So hopefully you see that from a 9-volt battery, I can induce a short duration voltage that exceeds 76 volts.